Hello, what's up guys? Good evening, it's Emmanuel here, and welcome to class 1 of the exam stack sponsored electronics and robotics class. So I'd like you to sit back and take it all in. It's very important we start this journey from here. I'll be going over the basics and then pointing out why you actually need to know this. So please stick with me till the end of this video. So what exactly is electricity? I find this question a little bit hard to answer directly because the word electricity actually has a few quirks in its understanding, or let me say explanation, which could be a bit confusing sometimes. And I'm actually not alone. You're actually not alone. No one is alone in trying to grasp electricity, because a lot of people, even scientists, somehow have a hard time grasping electricity as a whole. So you tend to have these, let me say, niche explanations of electricity. So for our purposes, we'll simply be saying electricity is when electrical energy is moved. That's it. So let's move on to what electronics is. Now, I don't know who else had this misconception, but I used to think electricity related to things that used higher voltages. I mean, electrical rather, higher voltages, and electronics was stuff that used, smaller voltages. But how wrong was I? So electronics is actually a branched word. It breaks down to electron mechanics, right? So essentially, electronics deals with the control of electricity or electrons here in a circuit, wherever, obviously to achieve a purpose. I mean, why would you have a circuit that achieves no purpose? You achieve this control with various devices, components such as resistors, capacitors, inductors, etc., connected in various ways across the circuit to do whatever. So we'll be saying voltage is actually the force responsible for pushing electricity in a conductor or across the circuit, right? Voltage is the guy running things. Physics definition now is the potential difference across 2 points in a circuit or across a conductor. A particular point in a circuit or across a component might be, say, 9, let's say, points of energy, and on the other end it's about, say, 0 points of energy. So the difference across that is 9, and then you can say you have 9 volts. And moving on now, what exactly is current? Well, we'll say current is the quantity of electricity flowing in a circuit. So what exactly is resistance? Essentially, resistance is a restriction or a limit to how much electricity flows. So basically, what that means is voltage helps you overcome resistance to allow current flow, right? So from this last statement now, I'd like you to think, maybe pause this video, whatever, and think, maybe get back to the WhatsApp group if you are actually on the WhatsApp group, and answer this question. What kills someone, when you maybe touch like an exposed live wire or something? What kills you? Is it the current, the voltage, or maybe maybe it's possible, maybe the resistance, right? So finally, we'll be defining the ohms and watts formula. So going over Ohm's law now. Ohm's law says the voltage across, say, a conductor is equal to the current flowing through it multiplied by the resistance offered to the current. And that's quite the same thing as the statement I made earlier, that voltage overcomes resistance, right, to allow current flow. That is, voltage is the force required to overcome that resistance to allow a particular amount of current to flow, right? So V equals to I times R. You use this formula, you become much more familiar with it, right? And then to calculate power dissipated, power available, whatever, power, electrical power in watts. It's simply how much voltage, right, is available, and let's say how much current is flowing. Okay, and that means P equals to V times I. So yeah, I guess that's for this video.